You open Google Maps, type in an address, and it gives you a route. 20 minutes later, mid-drive, it quietly reroutes you onto a street you've never taken. You don't question it. You just follow the blue line. Nobody does, but that reroute wasn't a suggestion. It was a live decision made in real time, using data from thousands of other phones on the road around you right now. Here's the part most people's mental model misses. Google Maps isn't finding you the fastest route, it's finding the fastest route it can give you without breaking the road it's sending you onto. Start with the basics. Under the hood, the base route comes from a straightforward pathfinding algorithm, the same family used in computer science for decades, that finds the shortest path between 2 points on a map treated like a giant network of connected roads. That gives you a starting point, not the answer, because a road isn't just a line with a length. It's a line with a length, a speed limit, a surface type, and right now, a crowd on it. So maps layers on live traffic, not from sensors bolted to the road, from your phone and everyone else's phone. Anonymized location pings from every Android and Maps user driving that stretch right now, showing exactly how fast traffic is actually moving, segment by segment. That alone would just tell you what traffic looks like this second. The harder problem is knowing what it'll look like when you actually get there in 15 minutes. That's where it stops being a map and starts being a prediction engine. Google trained machine learning models on years of historical traffic patterns for every road segment. What this street looks like on a Tuesday at 5 p.m. versus a Sunday at noon, then blends that history with what's happening live right now to forecast where congestion is about to build before you're stuck in it. This is also why the route changes mid-drive without a crash or closure. It's not reacting to what happened, it's updating its forecast of what's about to happen and resolving the whole route around that new prediction. Now here's the twist. The same one that shows up anywhere, a system is serving thousands of people at once. If Maps sent every single driver on the same route, the same shortcut the moment traffic got heavy, that shortcut would instantly become the new traffic jam. The system has to actively avoid creating the exact problem it's trying to solve. So it doesn't just optimize your trip, it has to keep an eye on what happens if a few hundred other people get the same suggestion at the same time. That's part of why two phones sitting next to each other at the same red light can get sent down two different fastest routes. It's not a glitch. It's the system deliberately spreading drivers across multiple viable paths so no single one collapses under the load. You experience that as your friend's ETA looking weirdly different from yours. The system experiences it as load balancing. There's a second filter working underneath all of this too. Not every technically shorter path gets offered. Routing also weighs road quality and structure, whether a road is paved or unpaved, a highway or a narrow residential street, because dumping a wave of traffic onto a small side street to save 90 seconds creates real-world risk that a highway lane change doesn't. So the fastest route isn't always the mathematically shortest one. It's the fastest one the system is willing to recommend, given what it would do to that road and to the people who live on it, which is the real reframe. Every time your route updates, it's not fixing a mistake. It's rerunning a forecast across live traffic, historical patterns, and thousands of other drivers, then deciding, again, what's fastest for you without wrecking the road for everyone else. You just see a blue line move. That's the version with all the math taken out.